Good day. Our topic for today is regarding rectangular components of vectors. Our topic last discussion during our face-to-face session is finding the resultant vector using triangle law. But triangle law is no longer ideal to use, especially if we're looking for the resultant vector of more than two vectors in a certain system. So say for example, you have here your first vector, then we have your second vector, then your third vector, then your fourth vector. Okay, such that the resultant vector is from the tail of the first vector to the head of the last vector. Okay, so for us to get the magnitude and direction of this resultant vector, we will have to apply the triangle law more than once. So for example, for these first two vectors, the resultant is this one. Okay, let's say this is resultant R1. So this is the resultant for these first two vectors. So this could now replace these two first vectors. So you now have a new representation of the vectors to which these first two vectors is now replaced with its resultant. Okay? Next is you have to get the first resultant and then the third vector, resultant of these two vectors, by again using triangle law. So you have to connect from here up to here. So this is now your second resultant. So this is now the resultant of this vector and this vector. So you now have, okay, this vector R2, okay, and then our fourth vector in the original system, then you have this resultant vector of all the resultant or of all the vectors in the original system. Okay, so as you can see, if we are going to use the triangle law for finding the resultant vector of more than two vectors in a system, we will have to use the triangle law multiple times, and that is no longer ideal. That really takes time. So other method for finding the resultant is by first expressing the rectangular components of a vector or of the vectors. Okay. In doing so, when you say rectangular components, it's also what you call, or if we are going to express a vector in terms of its rectangular components, it's also what you call the Cartesian form or vector form. So when you say Cartesian or vector form, say we will be considering a plane system. In a plane system, the Cartesian coordinate system is that you have the horizontal axis as the x-axis, and usually to the right is the direction of the positive x-axis, to the left is negative, and then upward or vertical axis will be your y-axis, and upward direction is the direction of the positive y-axis. So say for example, we have a simple vector A. Okay. If we are going to project that to if you're going to project that to the x-axis, when you say project, okay, you draw a line from the arrowhead into the x-axis, and this line, this is what you call the projection line, it should make 90 degrees with the x-axis. Okay, so this is now the x component of the vector A. Okay, there. And then, if you project that to the y-axis, so therefore, you will connect the arrowhead to the y-axis and make sure this projection makes 90-degree angle with the y-axis. Okay, so therefore, this line, okay, is now the y component of vector A. And by the way, this one, the length represents the magnitude of vector A. Okay, so when you say Cartesian form or vector form of a vector, so you have vector A, okay, it's now equal to its x component or magnitude of its x component. Okay, you multiply it to the unit vector I. So I has this is only has a value of 1. So if a magnitude is multiplied to I hat, this means that this magnitude is the x component of your vector. Then you have plus ay times j hat. Okay, so j hat means that ay, or the magnitude of ay, is the y component of your vector A. Okay, so I hat and j hat helps us to identify whether this magnitude is the x component or y component, and this magnitude is whether it is x or y component. So if it's beside I hat, therefore this is the x component. If beside j hat, this is the y component. So if a vector has a given magnitude and direction, usually from the x-axis, so therefore ax is equal to a cosine of theta by trigonometry or by SOHCAHTOA, and then you have ay, the y component, is equal to the magnitude of a. So pwedeng a lang, pwede din enclosed in vertical bars, meaning it pertains to the magnitude, then sine of theta. Why is it cosine? Why is it sine? Cosine because ax is adjacent to the given angle, and ay, okay, from this right triangle, the height of this one is also ay, and ay is opposite from that angle theta. There are times that the angle is measured from the vertical. So let's say its angle from the vertical is alpha, wherein alpha is 90 minus theta. So it could also be that ax is equal to magnitude of vector A sine of alpha. Okay, sine now because alpha is opposite to the ax. So this is also ax. Then you have ay that is equal to a cosine of alpha. So it actually depends on the given angle also, whether you use sine or cosine. So if the vectors are expressed in Cartesian form, this helps us identify the resultant vector or the addition of vectors. So say for example, you have two vectors given vector A, wherein vector A is axi plus ayj, and you have vector B equals bxi plus byj hat. Okay, so if we are going to add the two vectors, then the resultant vector R is simply equal to, okay, for the I hat, the x component of the resultant vector is simply the addition of all the x components of the vectors. Ax plus bx, then plus for the j hat or the y component of the resultant vector r, you just add ay plus by. So generally, resultant of two or more vectors is equal to, you just sum up all of the x components in the given vectors in the system multiplied to I hat plus summation of all forces y component of the forces or of the vectors times j hat. Okay, so this is the general formula for the resultant vector or addition of vectors using the Cartesian form or vector form. Okay, so now we will go back to our previous example. So these are the examples that we answered using triangle law. So let us now try to solve them using rectangular components. So just refer to my uploaded module 1 for as reference when you follow the discussion for this lecture video. Okay, so our first example, we are given two vectors. So we have vector A, okay, with a magnitude of 60 newtons and an angle with horizontal of 30 degrees. Okay, and then for another one for 100 newtons, this is for vector B, and it has an angle with the horizontal of 70 degrees. Now, for angle A, okay, so this is the y component and this is the x component. Okay, so let's express first each of the two vectors in terms of Cartesian form. So this is by, this is bx. So for ax, that is 60 cosine of 30. Okay, and then for ay, that would be 60 sine of 30. Okay, so we take positive sign or we use positive sign for expressing these vectors. Why? Because they are located in the first quadrant of the system. So since ax is to the right, directed to the right, remember you have to always follow the direction of the original vector for its components. So in this case, for the horizontal component, it's to the right, and then for the y component, it's upward. So both of them are taken as positive values. Okay, so we have 60 cosine 30. By the way, make sure first that your calculator is in the degree mode because the angle that we use is in degrees. So that's 30 square root of 3. So sometimes I would write the exact value so that I will have more accurate results. Okay, so of course that is still in newtons. Okay, then you have 60 sine 30. Okay, so you now have 30 newtons. Next, so we could now express the vector A in Cartesian form. So we have 30 square root of 3 I plus 30 j hat. Then you also write the unit. Okay. Next, for vector b, so bx is 100 cosine of 70. Okay. Also positive because it is directed to the right. So we have 100 cosine 70. That is 34.202. That is in newtons. And then our by, 100 sine of 70. This is also treated as a positive value because our by is upward. So that is 93.969 newtons. Okay. So therefore, our vector b in Cartesian form is, you have 34.202i plus 93.969 j hat. This is in newtons. So, for us to get the resultant vector, we simply add the two vectors, and when you add two vectors, you add their x components. So, all of the I hat values, you just add them. For the I component of the resultant vector, then for the j component, you just add all of the j components of the two vectors. So, for I hat, you have 30 square root of 3 plus 34.202. Then for j hat, you have 30 plus 93.969 j hat. So for the I hat, you have 30 square root of 3 plus 34.202. Okay, that's 86.16 I hat plus for j hat, we have 30 plus 93.969, 123.969, or we could round it off to 97 j hat. Therefore, this is now the x component of resultant vector of a and b, and this is the y component. So since both are positive, therefore the direction of resultant r is on the first quadrant. Okay. So this is now your resultant of a and b. Okay. So this is the Rx. Since positive, the result is positive Rx, then it is to the right, and Ry is upward. Okay. Now, of course, this is 90-degree angle. So this is 123.97. This is 86.16. Okay. So this is the angle, and then this is the magnitude. Okay. So for us to get the magnitude, okay, Pythagorean theorem, x component squared plus y component squared square root of the sum of the squares of the legs. No, this is from Pythagorean theorem. Okay, if you're not familiar with Pythagorean theorem, so if you have a right triangle, okay, these are the legs A and B, and the hypotenuse is C. So you have square of the hypotenuse is equal to the sum of the squares of its legs. Okay, so r squared. So para makuha ang r, then we square root both sides. So yan, r na lang naiwan, and then square root sa kabila. So we have square root of 86.16 squared plus 123.97 squared. 150. So we have 150.97. I believe this is also the result when we used triangle law for this problem. Okay. As for the angle, so in this given right triangle, the opposite side of theta and the adjacent side of theta is given. So opposite, adjacent, then we use tangent. So the opposite side is 123.97, the adjacent side is 86.16. So therefore, theta is arctan of 123.97 over 86.16. So have arctan of 123.97 over 86.16. That is 55.2. Okay. So this is now the angle of direction and the magnitude of the resultant vector r. And for its components, you have x component 86.16 and y component 123.97. So again, for the Cartesian form, you always have to write the unit of that vector. Okay, next problem. Okay, we have this problem as our next problem. By the way, I would just like to confirm, why do we add I hat and j hat? We simply add I hat and j hat for the determination of the resultant. So again, if you have two vectors, so as for like in our previous example, okay, so we have this is first vector and then second vector. So this is now their resultant of A and B. Okay. This is the resultant vector R. Okay. So, this one is AX. Okay. This one is BX. Okay. Next, this one, this is AY. And then, this height is BY. Therefore, for RX, this is your R. So, therefore, this entire length is Rx. Wherein, as you can see, for the x component of the resultant, you just add AX and BX. So, therefore, Rx is simply summing up forces along x-axis. And for Ry, this is your Ry. No, kasi ito yon. So, yung Ry, ito lahat. Rx, ito lahat dito. So, ito yung this is now your Ry. So, Ry is simply AY plus BY. So, therefore, Ry is simply summation of forces Y components of the forces. Okay. We now proceed to the next sample problem. Okay. So, this one. Okay. So, let me just redraw it so that it would be more clarified. So, this is F2, 150 newtons. The angle is 10. Okay. This is F1, 100 newtons. The angle is 15. Okay. We will now determine the magnitude of and direction of the resultant force. So, first, we have F1. So, for F1, since this is the direction of F1, okay, this is the F1Y. This is the F1 x. For F2, okay, this is F1x, F2x rather, and then this one is F2y. Okay. For F1, you have, for the x component, that's 100 cosine of 15 I hat plus 100 sine of 15 j hat. Sorry. Okay. Cosine, because this is adjacent to this vector, and then Fy, opposite side of 15, so sine. Okay, both are positive because both are in the direction of positive x and positive y. So we have 100 cosine 15. So 96.59 plus, okay, we have sine here. This would be 25.88 j hat. This is in newtons. This is also in newtons. Okay, we now have vector for F1. Next, we have to determine the vector for F2. Okay, for F2, okay, this is the x component. Now, for the given angle, okay, we do not usually use cosine for the I hat. Okay, it depends on the given angle. So, in this case for F2, since the angle given is from the vertical, so therefore, we have to use, for this 10-degree angle, we have to use sine for F2x because this is opposite the 10-degree angle. So, we now have 150 sine of 10 I hat for the x component, and for the j hat, cosine 10 degrees because this is adjacent to the 10-degree angle. You have j hat, then you have newton. So you now have F2. So you have 150 sine 10 plus, 150 sine 10. So that is 26.05. Okay, for the j hat, you need a cosine 10. 147.72 j hat. Okay, so we already got the vector forms of the two given vectors. So for the resultant, you just add F1 and F2. Okay, so for adding F1 and F2, we add all of the I components. So 96.59, plus 26.05 I hat. Okay, so both of them have positive x and y components because both of them are, the direction is in the first quadrant. So yung j component, so we have 25.88 plus 147.72 j hat. Therefore, resultant R is, okay, we have 96.59 plus 26.05. We have 122.64 I hat plus, okay, this one 25.88, 147.72. We have 173.6 j hat. Okay, so since I hat is positive, so therefore Rx is to the right, and since j hat is positive, Ry is upward. Okay, so this is 173.6, 122.64. Therefore, this is your R vector. It's also in the first quadrant. So we need to get the magnitude and the direction. So for the magnitude, Pythagorean theorem, square root of 122.64 squared plus 173.6 squared, that will be 122.64, 173.6, 212.55 Newton. So if you compare this to our solution using triangle law, so of course, they give the same value. Okay, for the angle theta, you have arctan of opposite side, 173.6. Adjacent side is 122.64. Okay. Arctan. Okay. So this is 54.76 degrees. Okay. Okay, we will now answer the third sample problem using ano yan, rectangular components or vector form. So this is quite different because you are not given the angle, but rather you are given a slope. Okay, so when you say slope, that's the rise over run. So along the line of action of P, there is a given rise. For this rise, 32 meters, the run is 16 meters. Okay, so this 32 by 16, since this is in meters, this is what you call the distance or the position vector. When you say position vector, that is the vector in terms of length or distance. So position vectors helps us find the vector form of the force vector that is in line with that position vector. Okay. So, if you opt to find or use the angle, okay, so let's say this is angle theta and this is angle alpha, okay, you could do so. It's not a problem. You already know how to find these angles in a certain right triangle. Okay? It's no longer a problem to you. You could get the same answer. But there is also another way of dealing with the position vector or using the position vector in finding the force vector Cartesian form. Okay, how do you do that? So for P, since we have this right triangle or its position vector from this point to this point, okay, the x component is 16 meters, the y component is 32 meters. Okay, now, for this right triangle, okay, you have 16, this is 16, and this is 32, and this is your theta. Okay, now, for this position vector, we could get the magnitude, this length itself. So, we just use Pythagorean 32 squared plus 16 squared. So, therefore, this is 16 square root of 5. So, instead of using sine or cosine of an angle, so you can see, your cosine theta is equal to 16 over 16 square root of 5. So, that is adjacent over hypotenuse. So, your adjacent side is 16, your hypotenuse is 16 square root of 5. Or that is simply 1 over square root of 5. Okay, properly, you write that 5 square root of 5, square root of 5 over 5, rather. Sorry. Okay? So, that is the same. 1 over square root of 5 or square root of 5 over 5. Because in the law of radicals, there should not be radical signs on the denominator. So although they are the same, but this is more proper, expressing values with radicals. But anyway, okay, instead of using cosine theta for this one, you will be using 1 over square root of 5. Okay, so as for the sine theta, okay, you will be using opposite side, 32, then hypotenuse 16 square root of 5. So 32 over 16 is 2. So this is 2 over square root of 5. Or that is also 2 square root of 5 over 5. So whether you use this or you use this, it doesn't matter. It's just the same. It's just that this is more proper because you find no radical sign on the denominator. But anyway, as we continue, okay, so if this is your P, this is Px, this is Py. Now, angle theta here for this distance vector is the same as the angle for the line of action of vector P. So for cosine theta, we could use this. For sine theta, we could use this. So, therefore, P vector equals, okay, hypotenuse of the P vector is the magnitude itself, 76. Then, cosine of theta for Px, that is 1 over square root of 5 I hat plus, okay, look at the direction of Px. This is to the left. So, therefore, this should be negative. Okay. For Py, it's upward, so it should be positive. So, you have the hypotenuse 76 times sine of theta 2 square root over square root of 5 j hat. Okay. So, you now have your force vector P, that is, okay, we have negative 76 divided square root of 5. Okay, so negative 33.988 then plus 67.98 j hat. So this is in kilo Newton. So you now have vector P. Okay, what did we do again? We use this position vector. So when you say position vector, that's the distance vector. Okay? So from this position vector, we are able to find cosine theta and sine theta. So let's just say that this position vector, we name this point as A. We name this point as B. Okay, so I want you to know the principle of what you call the unit vector. Okay. When you say unit vector, we have lambda, okay, as the denotation for the unit vector. Unit vector means the magnitude is only 1. Okay? So, for a certain vector or for a certain direction, the unit vector, you are only getting a unit of 1. Out of the total magnitude, you are only getting a unit of 1. That is what you call the unit vector. So, what we actually did here is by applying the concept of unit vector. Okay. Now, okay, in here, we use the unit vector wherein along P or along the line of action of P, okay, we only get a unit of 1. Okay. and then say this is the unit vector for P. Okay, so again, we only get a magnitude of 1. So, out of the total length, kuha ka lang ng 1. Yan ang unit vector ni P. Okay? So, how do we get the unit vector? Okay. For any vector along the unit vector, pareha lang lahat ng unit vector. So, since ang vector AB, position vector AB, is in line with vector P, they have the same unit vector. Okay. Paano makuha ang unit vector? Unit vector, magnitude pala ng unit vector yung 1. Okay. When you say unit vector is equal to the original vector, let's say vector F over its magnitude. Okay? Therefore, a certain vector F, from this formula, a certain vector F is equal to the unit vector multiplied to the magnitude of the force vector or of the given vector right here. Okay? So, in order for us to get the vector P, we need to multiply its unit vector to its magnitude. Okay. How do we get the unit vector? Remember that the unit vector of P is the same as the unit vector of the position vector AB. Why? Again, because they have the same line of action. They lie on the same line segment. Okay? So, since ang kagandahan nito, we could get this because this is equal to unit vector of AB. And AB has a given X and Y components. Meron ba? Yes. Okay. This is AB. Position vector AB has a unit vector of, X component of 16 and Y component of 32. So, therefore, this is equal to the vector itself divided by the magnitude of vector AB. Anong magnitude ng vector AB? The length of AB itself or the distance AB itself. Therefore, magnitude of AB is 16 square root of 5. Okay. So, ang ating vector AB ay ito, X component of AB, 16. 16 is to the right, no? Kasi we have to follow the same direction, A to B, because the direction of P is from A to B, so dapat the vector that we should use is from A to B. Okay? So that we could be consistent with the unit vector. So, ito, then ito. So, X component ni AB is negative 16 I hat, then plus 32 J hat. Yan, 32 upward. And then, what is the magnitude? 16 square root of 5. Okay. Therefore, for the I hat, okay, you just distribute the denominator with each of the terms in the numerator. So, you have negative 16 over 16 square root of 5 I hat plus 32 over 16 square root of 5 J hat. Okay. So, therefore, the unit vector for AB is equal to, okay, simplify, so we have negative 1 over square root of 5I plus 32 over, 2 over square root of 5 j hat. Okay, now, since unit vector of P is equal to unit vector of the position vector AB, therefore, this is also unit vector for the force vector P. And therefore, for the force vector P, okay, this is your unit vector, negative 1 over square root of 5 I hat plus 2 square root of 5 j hat. Then, multiply sa magnitude ni P. Ano magnitude ni P? 76. Oh. This is a scalar value. This is a vector quantity. Question, could we add a vector quantity with a scalar quantity? Yes. How? We just distribute the scalar quantity with each of the terms in the vector form. So, for the I hat, we have 76 times negative 1 over square root of 5 I hat. Then, distribute here in the j hat plus 76 times 2 over square root of 5 j hat. Therefore, okay, isn't this equal here in the first method or first approach that we used? Okay. Why is this important? I know that you are thinking that this is much simpler approach of the principle, but this is important because if we will have three-dimensional vectors, we will have to go through this kind of approach. Okay? So, you also have to be familiar with this one. Okay? So, anyway, you have the same result, negative 33.98 8I plus 67.98 j hat. This is in newtons. This is just for the vector P. How about the vector Q? Okay, so let us say for the vector Q, you have this line. So let's say this point is point C. Okay, we'll get a separate sheet for that. So this is Q. Okay, this is vector Q. Okay. Okay, again, we name this C, point C, and then point A. Okay, so for the position vector or distance vector AC, the Y component is 6 meters, the X component is 24 meters. Okay, yan. So, for Q, this is QY, and this is QX. Okay. Yung position vector na AC, okay, this is now your position vector from A to C. Take note that the position vector that you are going to use for in getting the unit vector of vector Q should be the same direction as that of Q. So, dapat from A to C, not from C to A, because the direction of Q is from A to C. So, for A to C vector, okay, the X component is 24 meters. The Y component is downward 6 meters. Okay. Now, we will be using the position vector AC. Okay. Now, magnitude of AC is simply 24 squared plus 6 squared square root just by Pythagorean theorem. Okay, that is 6 square root of 17 meters. Okay, so this is 6 square root of 17. Okay, now, vector AC, position vector AC has an x component of 24i plus, or rather, minus 6j. Why minus? Because the y component is downward. Positive 24 because it is to the right. Okay. Next, remember, AC, position vector AC, and force vector Q are lie in the same line or direction. Therefore, the unit vector of position vector AC is the same as the unit vector of Q. Okay, so along this line of action, unit vector is the vector along the line with a magnitude of 1. Kuha lang tayo ng 1 unit. Okay? Ayan. So, we could not yet determine the unit vector of Q using the vector Q itself. We may have the magnitude but we don't have this one yet. So what we will use is the advantage of having the position vector AC, which is the same direction as that of vector Q. So we will just use unit vector of AC, wherein that is the vector itself over the magnitude. So again, unit vector is equal to vector over magnitude. Okay? So, vector AC is 24i minus 6j, this one. And then, the 6 square root of 17 is the magnitude. So, individually, you have 24 over 6 square root of 17 I hat minus 6 over 6 square root of 17 j hat. So, therefore, the unit vector of AC, which is also the unit vector of P, is 24 over 6, that's 4. Then, you have over square root of 17 I hat. Okay. Then, we have minus 1 over square root of 17 j hat. Remember, unit vectors are always unitless. So, wag kayong maglalagay dito ng newtons or meters or what. Unitless siya. Kasi, bakit? This is in meters. Baba, this is in meters. Cancel. Okay? So, unitless ang unit vector. Okay, we now have the unit vector for P. Therefore, the vector, okay, from here, if unit vector is vector over magnitude, therefore, vector is unit vector times magnitude. Okay, so for P, vector P, the unit vector of P multiplied to the magnitude of P. Ay, PQ pala, sorry. Q. This is Q, sorry. Yan. Okay. So, this now helps us. So, unit vector of Q is again this one. So, you just multiply individually with the magnitude. So, magnitude of Q is 52 kilonewtons. Okay, this is 52 kilonewtons. Okay, 52 times force per square root of 17 I hat minus 1 over square root of 17 j hat. So, distribute, you have 52 times 4 over square root of 17 I hat minus 1 over square root of 17 j hat. Okay, for Q vector, therefore you have 52 times 4 over square root of 17, 50.45. I hat, j hat is, sorry, dapat naka-multiply pa dito yung 52. So, 52 times, okay, 52 times 1 over square root of 17, that is 12.61 j hat. Okay, this is in newtons. So, ito, naka-newtons, ito, unitless. So, i-adapt mo lang ang unit ng magnitude. So, which is of course in newtons. Okay, so, we bring back the vector P that we solved previously, that is negative 33.988. And then, we have 67.98J. This is also in, kilonewtons pala, sorry. Okay, kilonewtons. Kilonewtons. The given magnitude is in kilonewtons. Okay, let me correct that. Okay, so therefore, the resultant of Q and P is, okay, we'll just add all of the I hat components. So that's 50.35 minus 33.988. So remember, you have to carry the sign. So that is 16.46 plus, okay, we'll just add, we have negative 12.61 plus 67.98, 55.37 kilonewtons. Okay, so the magnitude of R is square root of 16.46 squared plus 55.37 squared. So, this is 57.76. Okay, there must be something wrong with our solution because it should be greater than, ito na yun. Okay, 57.76, and then yung angle. So, since positive itong dalawa, ang ating R is on the first quadrant. So, therefore, the angle theta, you have Ry, Rx. So, of course, this is your Rx, this is your Ry. So, theta is arctan of Ry, 55.37 over Rx, 16.46. Okay. .44 degrees. Okay, so for the next sample problem, I want you to try answering this one. Okay, wait lang. Ayan. So as you can see, there are 3 vectors. Pero follow pa rin that to the right is positive x, to the upward is vertical. So, I challenge you to answer this on your own. So, same concept for the resultant vector of these 3 vectors, f1, f2, and f3. No? Add lang lahat ng x components, that is I hat, tas add lahat ng j components, y components, that is j hat. Okay? So, kunin muna ang vector form ng 3. Tapos, lahat ng I i-add, lahat ng J i-add. Kuha ng magnitude. So, x component squared plus y component squared, square root of that is the magnitude. Okay? So, pag ang aking idea, I will give you a hint. If you have a vector that lies directly on the y component, if it is directly on the y component, it has no x component. It has no I hat. And its j hat is automatically the magnitude itself. So for this 50 F3 50-pound force, so its Cartesian form is 50 negative 50 j hat pounds. So it has no I hat, and negative 50 because it is the j component is downward. Okay. If your vector acts directly along the x component, it has an I hat. Its I hat is the magnitude of the vector itself. Then it has no j hat. As simple as that. Okay.